All right, so we're going to look at number 5 from the 5.1 homework. Okay, the problem. Most studies report that when U.S. gas prices rise by 10%, the quantity purchased falls by 1 to 2%. Okay, so the first thing I'm going to do when I see that is I'm going to make sure that I realize that there was just a piece of information given to me in word form, and I want to put it into the form that we use in economics, right? So most studies report that when gas prices rise by 10%, the quantity purchased falls by 1 to 2%. So what I know here is that they're telling me that the price elasticity of demand for gasoline is either 1/10 or 2/10. Okay, that's what they just told me. Okay, or 0.1 or 0.2. In September 2005, the average retail gasoline price was $2.90 a gallon, about $1 higher than a year before. But purchases of gasoline fell by only 3.5%. Now, if I'm doing a section on price elasticity of demand, I'm pretty certain that this question is probably going to be dealing with price elasticity of demand, right? And I just got a whole lot of information towards figuring out what the price elasticity of demand for gasoline actually is, right? So what we're looking at here is the hypothetical thanks to the studies, okay? And I'm actually going to go up into this area right up here to do this next part, okay? And what I got was that the new price is $2.90. The old price is $1.90, okay? And then we get, if we work it all out, we get 2.4 as the denominator, right? And how do we get 2.4? Because the denominator would be the new price plus the old price, right? Which is 4.8 divided by 2, which is 2.4, okay? So we get 1, after we do that math out, over 2.4, which is approximately what? Anyone? It's about 0.416 repeating, right? It's about 0.416 repeating. Okay, which is about 0.4167, right? Multiply by 100, and you get 41.67 is our percentage change in price. Okay, is 41.67. Now, that's the information we have right now. And that we know goes on top of, or underneath, excuse me, right? That we know over here goes underneath our percentage change in quantity demanded, which is 3.5%, and that was given to us right here. Okay? Now, so our price elasticity of demand for a gallon of gasoline is 3.5 over 41.67. Okay? Now, we've got a lot of information. Now let's go to the problem. It asks, in the year September 2005, the percentage change in the price of gasoline was? Well, we just did that, didn't we? And that percentage change was 41.67. So that is going to be our answer there. And the price elasticity of demand was, right? And we actually have that already in fraction form here. And if we did that out, it would be 0.08. Okay? If we did that out, it would be 0.08. Okay? And I'm going to make that an arrow and that an arrow so we're consistent and so that you don't think it's actually a negative. Okay? Now, our new PED then is 0.08, the actual price elasticity of demand for gasoline in the year to September 2005 is 0.08. The estimated price elasticity of demand for 2005 then is what? Smaller or greater than 0.08? It's smaller. Excuse me, then this is smaller than 0.1 or 0.2, right? Which we decided up here from the first sentence. Okay? Now, then we get to the last part, right? Which says the difference might be explained by, okay? And we have a bunch of different options. Option A is the development of clean fuels that are close substitutes for gasoline. Now we know that when the availability of substitutes increases, what happens to the elasticity of a good? Does it become more elastic or less elastic? Availability of substitutes makes the price elasticity of demand for a good more elastic. That's right, more elastic. So if it were to be more elastic, would we actually have a less elastic price elasticity of demand? So does that make sense? No, it does not make sense, right? Option B, higher incomes increasing the demand for gasoline. Now, if the demand for gasoline went up because people were able to purchase more gasoline, would that explain why the price elasticity of demand for gasoline actually was lower than what was expected? Yeah, that makes a little bit of sense, right? People are willing to buy more at every given price, right? When we see a shift in the demand curve like that. Okay, so option B is a good one right now. Then we go to option C, and we see improvements in public transportation decreasing the demand for gasoline. Now, improvements in public transportation means improvements in a louder substitute. Improvements in a substitute. If substitutes are improving, that means they are more available, which means what will happen again to the price elasticity of demand? It would become more elastic, making this not the appropriate answer. And D, a change in preferences toward clean energy, decreasing the demand for gasoline. Does a decrease in the demand for gasoline make any sense in this scenario, since we decided that they actually bought more than estimated? No, not at all, right? So it turns out that our answer here is B, higher incomes increasing the demand for gasoline. Okay, does everybody understand that? Okay, good. Now, jump over real quickly to number 10. Okay, and again, this is a different problem than what you saw in the homework, but it's only different by numbers. It's not different by concept, and so we'll work it out, right? The table on the right gives the demand schedule for peanuts. When the price of peanuts falls from 80 to 40 a packet, what is the change in total revenue? Okay, so what we're going to deal with is we're only going to deal with these two parts of the table. Okay, we only care about the quantity demanded at 80 cents per packet and the quantity demanded at 40 cents per packet. Now, total revenue, we know, is calculated by the price per unit multiplied by the total quantity demanded of that unit, right? And so if we do the math out here, we'll go, since we're going from 80 to 40 cents, right? We're going to start with 0.8 times 250 equals 200. Okay? And then we go 0.4 times 350 equals? 360? Nope. 140. Okay? 140. So our difference is 60. And if you read below, so the total change in revenue is $60. And we're losing $60, right? So if you read below, it says if the total revenue decreases, include a minus sign. So when we put it in here, we're going to put minus 60 as our answer. Okay? Now, it also says that do not include a plus sign if the revenue increases. That's because computers are computers and they're not set to accept a plus sign, right? So they wouldn't count it. Now, Next, we have the question, over the price range of 40 cents and 80 cents, the demand for peanuts is what? Uninelastic, elastic, or inelastic. Now, based on what we know, we could do either one of two things. We could go back to our formulas, right? And we could draw up that the price elasticity of demand equals the percent change in quantity demanded over the percent change in price, right? And then we do the midpoint method for the percent change in quantity demanded, and then we do the midpoint method for the percent change in price, and then we do the math out, right? Or we could know that if with a decrease in price, there is a decrease in total revenue, that we are dealing with an inelastic scenario. Okay? If a decrease in price draws a decrease in total revenue, your good, the price elasticity of demand for that good must be inelastic. Does that make sense? Okay? It basically means that that difference, the total revenue, right, went down. That can't happen if that many more people would buy it based on the decrease in price, right? And so it's not necessarily 100% of the time, right? But a good 90 to 100% of the time, it is right. And so you're going to find that that's a really good way of looking at it. Now, I promise you, when you do the math out for this one, it ends up to be 1/2, okay? Which means that it is less than 1, making it inelastic. Okay?